Okay, I'm very happy to talk to you about one of my favorite topics, which is automatic sign language processing. And nowadays, this happens almost exclusively in a data-driven manner. So I want to start by giving you some background on sign languages. And by the mere fact that I'm using the term sign languages, you can tell that there's not one universal sign language, but there are actually we believe about 120 sign languages to date that are documented, so that have been explored and researched. But there are more out there, we know that. And it's also the case that some sign languages, especially the locally very restricted ones, die out. Sign languages are actually fully developed linguistic systems, so they're natural languages in our sense, just like the spoken languages that we're most familiar with, like English and German. And so automatically treating sign language is really a case of natural language processing. In Switzerland, we actually have 3 different sign languages. We have Swiss German Sign Language, which is different from German Sign Language, the way it's used in Germany. We have Swiss French Sign Language, and we have Swiss Italian Sign Language. And those 2 languages are actually believed to be varieties of the sign languages that are used in France and in Italy. With sign languages, what is important is not just what goes on with the hands and the arms, which is what we probably typically think of when we hear the word signing, but what's actually equally important and has been shown to be capable of actually carrying linguistic meaning are the so-called non-manual components. And that's everything that happens in the face, for example, with the shoulders, the upper body. So when we think of building sign language technology, we really need to also take into account these non-manual features. So what is automatic sign language processing? Typically, we subsume 3 different applications under this term. One is sign language translation. This involves going from either a spoken language or a sign language to either a sign language or a spoken language, or going from one sign language to another sign language. And then there's sign language synthesis, generating signing avatars, so producing synthetic sign language, really. And lastly, we have sign language recognition. Nowadays, mostly this involves applying computer vision techniques. So starting out from a video of a signed utterance and arriving at a transcription of what is being signed. And this transcription ideally would be one that describes both the form of what's being signed and also the meaning. Yeah, so this is an example of signing animation, so a sign language synthesis, a signing avatar, signing the sign for ball in English. With sign language recognition, if we think about what the possible applications of these individual technologies that I just mentioned are, sign language recognition can be used to speed up the process of corpus annotation, for example, so either automatic or semi-automatic, at least, corpus annotation. I will show later on that that's really the bottleneck in creating sign language data that can be used to train automatic sign language processing systems. And then we can use sign language recognition for something like a search by example interface. Think of the case where a user of a sign language lexicon wants to search for a certain sign, and then he or she can either do so by looking through a list of entries, sorted alphabetically, for example. But it's also possible, and this is a more natural way of searching in the case of sign languages, so this actually corresponds to a natural user interface. It's also possible to sign something in front of a camera and have the system, the lexicon, provide results for what was signed. So give back signs that were most similar to what was signed. And this is what people are actually working on. So natural user interfaces for sign language lexicons, for example. And then sign language recognition can be used together with sign language assessment. And I think this links nicely to Helen's talk. I'll talk about this later. This is a project that I'm involved in, so I'll give some examples for this. Sign language synthesis in isolation has, I think, an application value in cases where either the potential for modifying is important, so sign language animations can be modified more easily than sign language videos of human signers, and also has a potential in cases where anonymity is key. So think of, for example, sign language wikis. That's something that is now being developed where we want to give users the possibility of staying anonymous, or blogs, for example, as well. And then, of course, the real benefit comes from combining these three individual technologies that I introduced to the end that we would have something like an information and communication technology system that would eventually enable deaf sign language users and hearing people to communicate with each other. This is still very much in the future. There are attempts at going in this direction, and our group has also contributed to this, but the individual applications, the three sign language processing techniques that I mentioned, are not sufficiently mature yet for this to work, but this is, I would say, our end goal. So what it would mean is that if we were going from sign language to spoken language, we would need to combine both translation and recognition, so have first a sign language recognition step, followed by a translation step. If we were going in the reverse direction, we would need a translation step, followed by a synthesis step. And if we were converting between two sign languages, we would need sign language recognition of sign language A, followed by translation, followed by synthesis into sign language B. Yeah, so the challenge is, and I want to spend some time following just after this slide to talk about what it takes to build data, good data for an automatic sign language processing system. The challenge really lies in, I think it's just the same as what Helen said before, lies in arriving at sufficient and high quality data. In fact, it's really, really time consuming to produce sign language data that's both transcribed and linguistically annotated. Before I started working on automatic sign language processing, my idea of a really, really time consuming annotation task was creating syntax trees, so syntactic annotation. But I can tell you this is nothing like creating syntax trees. In fact, there are estimates, and these have been shown in different scenarios and different groups around the world, that it takes about 600 minutes to annotate, to transcribe and annotate 1 minute of signing, so factor of 1 to 600. So it's crazy, time consuming, and this is really the bottleneck. Yeah, so of course, in creating sign language data, first we need video data. And there it's been shown to be beneficial to use different types of cameras. So for a project that I'll talk about at the end, we used, for example, a Kinect sensor that gives us skeleton data as well as depth information. We used two different types of GoPros, one that was that ran at a high frame rate in order to minimize motion blur, because movements in sign language can be quite fast. And we used a GoPro that had a very high resolution, and this was to be able to discover the subtleties that went on, for example, in the face, to do with the non-manual features that I mentioned. So for example, eyebrow movements, the head moving forward just very slightly, things like that. And then we also used additional cameras for linguistic analysis that would give us different angles. So one camera from each side and then a camera from the top, just in order to be to get additional information. So once we have the video data, we need a way of arriving at a written representation of what we have in the video data. And there's no really widely accepted writing system for sign languages. So deaf signers in their everyday life, they don't write sign language. So any notation that we have is really a notation, a scientific notation, an expert notation. And what we want is both a notation that can give us information about the semantics of the signs in the videos and about the form of the signs. For the semantics, what we typically use is something that's called gloss notation. These are just uppercase spoken language words that give us indications of the meaning of the signs that are used. For form, what we use is, this is really a notation system that's been shown to be most applicable to automatic sign language processing, a system that's called the Hamburg notation system for sign languages, or HAMNOSYS for short. And what it does is it provides about 200 symbols to describe what's going on in terms of the physical form of the signs. So in terms of the hand shape, and you can see the symbols are quite iconic. So without actually knowing sign language, which I presume is the case for most of you, you can probably tell that this indicates that the sign has an open 5-finger hand, so fingers spread. And then we have symbols that refer to the direction of the extended finger or fingers and to the orientation of the palm, as well as the location, so where the sign is being performed. Here, in this case, it's being performed around in this region and to the right of my body. And then we have information about the movement, which in this case is a circular movement that is repeated once. And altogether, this gives us information about what's going on. This is a sign folk. It's performed like this, 2 circular movements. Folk is the name of my former PhD advisor, so I like to use this example. We also have codes for denoting the non-manual aspects of signs. So for example, raised eyebrows, noses that are wrinkled, heads that are pushed forward, shoulders that are shrugged, things like that. And then, of course, if we think about sign language machine translation, what is really most useful is parallel data. So ideally, we would have something like what's depicted here is a German sentence linked to, aligned with glosses in a sign language, for example, in Swiss German Sign Language, along with information on the non-manual components of the signed utterance, along with these HAMNOSYS symbols. And if we think of a runtime scenario, so think of this as the output of our of a productive machine translation system, what we could do is we could then use this output as input to a sign language synthesis system. So this is an XML representation. It's not about being able to see the details, I think, but just to know that there's this XML representation that holds all of the information that the machine translation process generates, and then takes this as input and converts it into animation data that can then be rendered and produce an animation. I want to briefly talk about another project that I'm involved in, which has to do with language assessment and sign language recognition. This is a Swiss National Sign Foundation Synergia project. And what we do is, it's actually almost finished, the project. We got a small extension and are in the process of wrapping things up. What we did was we created, as a prototype that came out of the project, a system that developed a vocabulary production test for hearing adult learners of Swiss German Sign Language, where the learners are expected to produce 100 isolated signs, and feedback for the production of these 100 signs comes from an automatic system. I have an early version of the prototype here with me, just so you get an idea of what it's about. So on the left we have the learner, on the right we have a reference signer, and the learner to the left produces a sign summer in English, and the sign is correctly produced like this, but the learner produces it using an incorrect hand position. And as you can see, the system picks up on this by circling the hand position just as the hand touches the upper arm, the upper left arm of the signer, highlights it using a red circle. So this indicates an error. Yeah, and these are the types of things that we're working on. I think my time is up. Yeah. And thank you very much for listening. I'll be happy to take questions.
I do have actually a short question about the data. Did you already consider the possibility to use some kind of bootstrapping method to create the data, like for instance, using TV news with these parallel version of of the news in the sign language? Did you already consider this possibility?
I'm not sure if I understood everything.
Sorry. Did you consider the possibility to use some kind of bootstrapping methods to create training data?
Yep.
Like for instance, using the TV news with the parallel version of the same news in the sign language.
Mm-hmm. Did you say TV news? The
exactly.
Signed version of TV news? Yeah, okay,
exactly.
Okay. Just wanted to make sure. Yeah, exactly. Yeah, that's a really good question. Yes, in fact, there's two problems with this. In fact, on the Swiss TV, as maybe some of you know, there is actually sign language interpretation for the main news and also for the weather reports. This has been done in the UK, actually, where transcripts of the signing exist. But the problem is twofold. There are the signers in these interpretations are actually signing interpreters, so they're hearing interpreters. And the idea is that those signers are not, they don't represent prototypical sign language, which would come from deaf native signers. So that's one, I guess, issue, one challenge. The other is that signing in such an interpreting setting happens under very demanding conditions. So interpreters tend to leave away information. They tend to follow more closely the structure of the spoken language, and those are properties of interpretation, because simultaneous interpretation is just cognitively very demanding. So, and there's not, and interpreters tend to have a lag, a time lag, and so they tend to reproduce the grammatical structure of the spoken language, in this case of German, for example, German news, whereas sign languages have their own grammar, and that is actually distinctly different from spoken languages. So we don't get as natural as sign languages as we would like from this. But of course the idea is good, and we do have this type of data. Of course one could think of mixing this sort of out-of-domain data, considering this a case of out-of-domain data, and maybe deprioritizing it, but still using it for a machine learning system. Yeah, exactly. Thank you.
Hi. In some of your diagrams where it was doing like a written sentence, one of the intermediate stages before going to the sign seemed to be that's the not simplified, but the written form of sign language. Does that include the nuances, as you mentioned, of like the motions in your face and arms?
It does if you have, I don't know if you remember, I had one, actually I used a simplified version that showed just this gloss notation. That wouldn't include any information on the non-manual components, but I don't know if you remember, on one of the slides I had a table that had different tiers that would record information on head movement, eyebrow movement, eye gaze, and so on. So you definitely need this as well, yep. Yeah, so it's actually a multilinear representation that you're aiming at in the case of sign languages. And the trouble, and to make it more challenging, is that the timing of these manual components and the non-manual components is not necessarily synchronous. So they don't start and end at the same time. Yeah, this makes it challenging but fascinating too, I think.
Yeah, thank you. It was really cool to see how many characters there were to represent what somebody was signing.
Isn't it? Yeah. It's cool, but it's challenging too. Yeah.
Thank you.
Thank you for this very interesting presentation. So I'm really curious about what is like the main challenge in order to achieve the end goal that is left, the most challenging topics for you.
Yeah. Data and money, which to some extent I think is linked. Yeah, the signers are just, they make up such a small group of people if you look at, and especially deaf signers. So there's not really a lot of money going into this. So to some extent it's a research problem. Although I have to say that there are companies that have started taking it up as I think Bianca mentioned in her talk, as something that corporations sometimes see as a responsibility in terms of diversity. Yeah. So, but data I think is the bottleneck. Yeah.
Thank you.
Thank you.
All right. Thank you very much.
Thank you.